Okay, let's begin. So yesterday we were discussing about Pyspark and what are the different transformations, actions, and how to create the data frames, everything, right? So today let us continue. So yesterday what all the things we saw? So we saw what are the data frames, okay, and we saw what are how to create the data frames with the help of three methods, okay. One is using the Python list, another one from RDD, and another one from external CSV file. So these are the ways how we are creating the data frames. And then we also saw the schema and data types, how to design the schema, okay, and we also saw how to display the selected columns, single column, multiple column, and how to modify the column, okay, and how to filter and display the results based on some conditions, okay. You can combine multiple conditions with the help of AND operator, and how to drop or add a new column, okay, and how to rename a column, and how to handle the missing data, how to fill the missing values, and how to replace the specific values. And what are the different data frame operations, what you can do? You can do the sorting by assigning order or designing order, and some aggregation functions like count, all these things, average, sum, minimum, maximum. Now we shall see data frame joins. So far what you have done? You have done joins in SQL, right? In SQL you have performed inner join, left join, right join, full join. Same thing here also you are doing. Same thing, okay. So concept, everything is same, but the query, there you were writing what? Query, okay. So here you are writing the code in a different way, okay. Here you are using the data frames, you are joining what? Data frames. There you were joining tables, okay. In SQL you are joining the tables, here you are joining the data frames, okay. So now if I have two data frames, okay, df1 and df2, I can join those two data frames with the help of different types of joins. So first we shall see inner join. Inner join, what it will do, what it was doing in SQL, it returns the matching row from both the table. Okay, so here it returns the matching rows from both the data frames. Okay, so that is the difference. So how we are going to perform the inner join? df1 dot join, inside the parenthesis you are giving df2, okay. df1 you are joining with df2 based on what? Based on what columns? id is the column, okay. And inner, what is the type of join you are giving? So that you have to specify here, inner, okay. Dot show. So after this what you will get? Two data frames joined using inner join, and you will get the final result after joining, okay. You are joining it based on the ID. In all the examples we are joining two data frames based on the ID itself. Only the type of joins we are going to change, okay. So next we have left join. Left join, what it was doing? It will return all the rows or all the data from the left and only matching rows from the right. So that was the thing it was doing in SQL. Here also same thing it will do, okay. So here instead of inner you have to give left. That is the difference. Everything remains same. And right join you have to specify right. Full join you have to specify full, okay, like this. And you can perform union and intersection, okay. Union means what? Two sets, two data frames taken together and combining them, okay. So df3 is equal to df1 dot union df2, two data frames df1 and df2 union, and the result is stored in df3. So you are using the union, and you can also use union all. So what is the difference between union and union all? So here in union there will not duplicates will not be there, but in union all it keeps the duplicates. Okay, in union if even though there are duplicates it will discard, but in union all it will keep the duplicates. Okay, and intersect, what does intersect do? It returns only the common rows from df1 and df2, only the common thing. Okay, so these are the union and intersection operations you can do with the data frames, and you can find out the duplicates and you can drop duplicates. Okay, so how you are going to find the duplicates? df.distinct.show. So this will find out the duplicates. Okay, if you want to drop the duplicates you have to use drop duplicates. So based on what? Name and age. Okay, so here you are going to find the distinct values and remaining all the duplicate values will be removed. Okay, next, you can use some basic math functions also here. Okay. So what are the things you can use? Round function, upper, lower, square root, okay, length, all these things you can do. For example, if you want to round off the salary by 2 decimal places, okay, then what you can do? Round df dot salary comma 2. And if you want to find square root of age, square root of df dot age. So only you are modifying this and you are selecting these columns. Okay, so df dot select, on what basis I am selecting? I am rounding off the salary and I am doing the square root for the age. And you can also find, apply the string functions. Suppose if you want to change the name to uppercase, or you want to change the name to lowercase, you want to find the length of the name, every string operations you can do here. Okay. Okay, then you can use this date function, conditional aggregate function. So for example, if I want to select the current date and show, you can do it. And if you want to select with the help of these conditions. Okay, so here in the second conditional functions, what I am doing? So the category, I have one category column. Okay, there I am mentioning senior or junior. On what basis I am deciding whether he is senior or junior? When df dot age is greater than 30. If the age is greater than 30, I mention it as senior. Otherwise, I mention it as junior. Okay, so based on some conditional function, you can create a new column and you can enter the values there. With column, for what purpose we are using with column? To create a new column, right? So to create a new column, we are using with column, and in that column what we are putting? We are putting the heading of that column as category, and inside that we are entering whether it is a senior or junior. Based on what you are deciding? Based on the age. So if when df dot age is greater than 30, keep it as senior, otherwise keep it as junior. Okay. And also you can use aggregation functions. I have already told you, group by, based on the average of salary you are grouping the departments. So this also you can do. And when it comes to file handling, here so far what you have seen, CSV file and JSON file, right? So here you have so many other files also. So Pyspark will provide you powerful methods to read and write the data in different file formats. Okay, pandas and all you were using the CSV and JSON, right? So here you can use Parquet files, ORC files, many kind of files this Pyspark will support you. Not only CSV and JSON. Okay. So here for reading the files what we are using, spark.read, whether it is CSV or JSON, that is followed after read. Okay. Then df.write for writing the files. Now we shall see how to read and write in the different files. So this is file handling with the help of CSV file. Okay, CSV file. How to read the CSV file? Df is equal to spark.read.csv. Inside that we are giving data.csv. That is the name of the CSV file. Header is equal to true. Info schema is equal to true. So if you mention header is equal to true, what is the name of that? The first row will be always column names. So if you specify infer schema is equal to true, it will automatically detect the data types. That means based on your data. So it will detect automatically. So in Python also you are not mentioning any data types, right? It will take by default. So in the same way here also, if you mention infer schema is equal to true, it will automatically detect the data types. Then this is how you read from the CSV file. To write to CSV file, what you are doing? df.write.csv. Inside that you have to mention the folder name. To which folder your file should be saved. So I am mentioning it as output folder. This is one folder in my system. Okay. In this output folder, my CSV file will be stored. Okay. This is how you read the CSV file and write to the CSV file and store it in one some folder. Okay. Then coming to JSON. Same thing here. Instead of CSV, what I am giving? JSON. Spark.read.json, give the JSON file. So if you want to write it, df.write.json, output JSON. Okay. So here header is equal to true, infer schema are optional. If you want, you can give it. Okay. Then comes Parquet files. So what are these Parquet files? These are something new for you, right? So you have not heard about Parquet files. So what is this Parquet file? So this is the compressed file. Okay. See, in big data analysis, what we are doing? We are dealing with a large amount of files in GBs and TBs, right? So in that case, what happens? If we compress that file, then the size of the file becomes smaller. Okay. So in such situations, we go for the Parquet files. So these are the compressed, smaller sized files. Okay. And so they have read only needed columns. See here, you can selectively read the columns. So in JSON and CSV, you have to read the entire file. But here you can selectively read the columns. Okay, so that is the difference. And it is very fast compared to CSV and JSON. Parquet files are very fast. And then, so by default, in Spark, it is preferred file format is Parquet file. Okay. Let us see how to read from the Parquet file and write to the Parquet file. So it is spark.read.parquet, mention the Parquet file, and df.write.parquet, mention the folder. So where it has to store. Okay. If you want, you can download some sample Parquet file from the Google or somewhere. Okay. You can check how the Parquet file looks like. Okay. If it is possible, I'll show you that also. So this is how Parquet files are basically compressed files. So that you should know that. And it is very fast as compared to CSV and JSON. Then, so here on the data frame, you can perform the SQL queries. I told you. Okay. On the data frames, you can perform the SQL queries. Okay. So before you perform the SQL queries on the data frame, you must register the data frame as a temporary table. So this is one step you have to do before you run the SQL queries. So how we can create the temporary view? df dot create or replace temp view students. What is the meaning of this? I am creating one temporary view. The name of the temporary view is what? Students. If it already exists, replace that. If it does not exist, create a view. Okay, fine. So this is temporary view. This is only session based. So out of the session, there is no scope for this temporary view. Next, if you want your view to be visible across all the sessions like global, you can treat it as local variables and global variables. Okay. Temporary view is local variable. Global view is the global variable. Okay. So here df dot create global temp view students. So now this view is visible across all the sessions. This is like a global. So if you want global, you can create this. If you want just temporary, you can create the temporary view. Okay. If you don't want that view, after you perform all the operations, you can drop that. Okay. Simply if you don't want that to exist, you can drop that view. So how do you drop a view? Spark.catalog.drop temporary view students. This is the method how you are dropping a view. So this is how we create the temporary view, we create the global view, and we drop a view. Okay, fine. If the view what you are creating already exists, that will be replaced. Okay, you have to be careful while giving name to the view. If it already exists, that will be replaced. Or if it does not exist, new view will be created. Now, once you create the view, you can run the SQL queries. Okay. For example, this is my SQL query. Select name, age from student, where age is greater than 20, order by age, descending order. So, this is one normal SQL query. So, how I am running this query? I am using result is equal to spark.sql. So, inside spark.sql, you have to mention your query with triple double quotes. Okay, since it is a full this SQL query requires multiple lines, I am enclosing it with the triple quotes, either triple single quotes or triple double quotes, both will work. Okay, now result dot show, your result of the query will be displayed. Okay, so this is how you can query your data frame. But always remember, before you query your data frame, you have to register as a view, either global view or temporary view. Okay, then so this creating and using views, we have already seen this. Okay, so first let us take one simple SQL query. Select star from employee. Simple SQL query. So first, to execute this query, what you have to do? You have to create the temporary view. Okay, how do you create the temporary view? Df dot create or replace temp view. Give the name of the view. Okay, this is the temporary view. Once you do this, then you can query. Spark.sql, give the query dot show. Here I am not using the triple quotes. Why? Because my query is in only one line. So you are using triple quotes, only your query is in multiple lines. Okay. So since it is only one line of query, single line query, I am using only the double quotes once. Okay, dot show. So here the all the records from the employee data frame will be shown as a output. Whatever the data is there in the employee data frame, that will be shown as the output. Okay. So you also have this functions, what these categories of functions, what you can perform on the data frame. One thing, string operations. Okay, just I told you, you can do uppercase, lowercase, length, trim, concat. Trim is for trimming the white spaces. Okay, concat is for joining the two strings. Okay, then you can perform mathematical operations, floor, seal, round, absolute, square root. What is the difference between floor and seal? Floor will round off to the nearest value, nearest small value. Seal will round off to the nearest large value. For example, you have a value like 6.3. So if you use seal, it will be rounded off to 7. If you use floor, it will be rounded off to 6. Floor will always round off to the less value. Seal will always round off to the more value. Okay, then you also have this date and time handling function. You can get the current date, difference of dates. Suppose your data frame has two dates, joining date and resigning date. If you want to know the difference, then you can use this date difference. You can add the date, year, all these things. You can have sum, average, minimum, maximum, count, distinct. Anything, whatever you are performing in SQL, no, so far, everything you bring here and you can execute. Okay, only thing extra you have to do is what? Create the view. Create the view, go on executing the SQL queries. You know already SQL, how to execute the queries, joins, everything. So just bring them into the big data, that's it. Okay, so this completes the almost all the concepts in Pyspark. Did you try the tasks? Two sets of tasks I have already given. Today one more set of tasks I'll give you. Just try them in the Databricks. Okay, so one more set of tasks I'll upload now, and I'll also give you some mini projects on that. Some like mini project means some lengthy kind of tasks. Okay, you can try them also. I'll just post task 3 and its solutions also. You can look at the solutions as well and try this now. By tomorrow, I'll send you the projects on those. Tasks 3. Okay, I have posted. You can check and you can start doing the tasks. Okay, so online people, any doubts? No doubts means you can start working with the tasks 3 I have uploaded in the classroom. Any doubts we'll discuss in the next class. You can start working. I'll come back.